In this video, we're going to apply a property of integrals to estimate a given integral. In this case, we have integral from 0 to pi over 6 sine of x squared dx. And the first part of the question asks us to show that sine of x squared is less than or equal to sine x for x between 0 and 1. So let's show that. We know that when x is between pi over 6 and 0, x squared is less than or equal to x, since x is larger or equal to 0, is less than or equal to pi over 6, which itself is less than or equal to 1. Now we know that sine x is an increasing function of x on the interval 0 to 1. That means sine of x squared is less than or equal to sine x on the same interval 0 to 1. We're going to illustrate this with a diagram. Here we have a graph of sine x on the interval 0 to pi over 6. And clearly you can see that sine of t squared has a smaller functional value than sine of t when x is between 0 and pi over 6. So that is how we're going to prove this. So t is less than or equal to 1, larger than 0. This implies that t squared is less than or equal to t. And since sine x is increasing on the interval, the closed interval 0, 1, then sine of t squared, the functional value sine of t squared, is less than or equal to sine t on the interval 0, 1. That of course means sine of x squared is less than or equal to sine x on the closed interval 0, 1. This is the proof of part A. Now let's look at part B. Alright, we want to prove that a definite integral 0 to pi over 6 sine of x squared dx is less than or equal to 1 minus root 3 over 2. We've already proven that sine of x squared is less than or equal to sine x on the closed interval 0, 1. Therefore, we know that sine of x squared is less than or equal to sine x on the closed interval 0 pi over 6, because pi over 6 is less than 1. Alright, so now we're going to apply a property of integrals. The integral from 0 to pi over 6 sine of x squared dx is less than or equal to integral from 0 to pi over 6 sine x dx. We're now going to apply the fundamental theorem of calculus to solve the right-hand side of this inequality. The antiderivative of sine x is negative cos x, evaluated from 0 to pi over 6. We get minus cos of pi over 6 minus cos of 0. Cos of pi over 6 from the diagram to the right is adjacent over hypotenuse. That would be root 3 over 2. Cos of 0 is 1. Let's rewrite this as a 1 minus root 3 over 2. This is an upper estimate for the integral 0 to pi over 6 sine of x squared dx. Alright, let's go over the theory that we applied in this question. So the theory we applied was a comparison property of integrals. If f of x is less than or equal to g of x on the closed interval ab, then the area under the curve of f of x is going to be less than or equal to the area under the curve of g of x. We expect that from the diagram. You can see that the green shaded area is less than or equal to the black shaded area in this case. Alright, thanks.